Alright, I'll be solving this problem today using log rules. Now you could solve it with quotient rule, but mathematicians are lazy, so we're going to do it the lazy way. So first you're just going to apply natural log to both sides. Like this, and it's going to be one giant other natural log in here. Now, we're not differentiating just yet, we're just going to keep applying log rules. Differentiating is the last step in most of these problems, or close to the last. So just keep on bringing that natural log of y down. I'm just going to break this apart. Still just using log rules. Parentheses there. Still just use your log rules, bring that natural log of y down. Now normally you'd split this up with addition, but since you have a minus sign here, you're going to split it up and use subtraction. So it's going to be minus natural log of 2x plus 1 all raised to the 2x plus 1 all raised to the third minus natural log of 3x minus 1 all raised to the fifth. One last step before we take the differential. We're just going to continue using log rules and bring that power down to the front. So natural log of y will be equal to 4 times the natural log of x squared plus 1 minus 3 times the natural log of 2x plus 1 minus natural log of 3 minus 5 natural log of 3x minus 1. Now you finally take the derivative. So for natural logs, it's just 1 over whatever's on the inside. So this is just going to be 1 over y. But since we're taking the derivative with respect to x, we need to include a dy dx. And so that's going to be equal to 4 over x squared plus 1. Now, the most important part is don't forget your chain. Since this one's derivative is not 1, you have to carry the chain. So it's going to be times this chain of 2x. Keep doing the same thing, minus 3 over 2x plus 1, so times this chain of just 2, and minus 5 over 3x minus 1 times its chain of 3. Now, the goal of this problem is to get dy dx by itself. So we're going to multiply y to this side of the equation, and I'm just going to condense all that multiplication all at once. So we're going to have dy dx equal to 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 over 3x minus 1 times our y. And even though we have dy dx by itself, we're still not done because we have the y there. Luckily, y is defined at the top of the problem. So we're just going to substitute that in, and that'll be our final answer. So, final answer is going to be dy dx is equal to 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 3x minus 1 times our y, which is x squared plus 1, sorry, all raised to the 5th over 2x plus 1 all raised to the 3rd times 3x minus 1 to all raised to the 5th, close out that bracket. Now yes, in theory, it is the simplest form. You could condense these two, but the problem didn't ask for that, and I don't feel like doing that, so that's going to be the answer to this problem.